Building scales. In this module, we're talking about how to build pentatonic scales and working with major scale as a foundation. So as you can see, our major scale without fa or ti results in a pentatonic scale. Because it does not have any half steps, we refer to this scale as being anhemitonic, meaning that it does not have any half steps. A hemitonic pentatonic scale would indeed have some half steps. So we can build pentatonic scales easily by starting with the major scale, C, D, E, F, G, A, B, and C, and erasing or eliminating fa and ti. That gives us a scale with a whole step, a minor third, another whole step, and another minor third. Your typical pentatonic scale will have this orientation, and I'm going to count half steps between adjacent notes. 2 half steps, 2 half steps, 3 half steps, 2 half steps, and 3 half steps. Sounds like this. Pentatonic scales sound very open, and all the notes are pretty much in harmony with each other. So if I wanted to write another pentatonic scale based on the note D, I could go through and count all these intervals, but I could also write a D major scale first and eliminate fa and ti. So my D major scale is first, and I can go over here and erase fa and ti to create a whole step, a minor third between F sharp and A, a whole step, and another minor third between B and D. As another example, we can start with A major scale, here's your A major scale, and I'm going to erase fa, the 4th scale degree, and ti. The result is a pentatonic and hemitonic pentatonic scale. So for your homework worksheet, you're asked to create pentatonic scales. We can do that here. Let me make my pencil a little bit skinnier here with the tip there. So this is C pentatonic. We've already sort of addressed that. C, G, and A. Sorry, this is sort of hard to write. G pentatonic would use the G major scale as its foundation, and we would eliminate fa and ti. So we skip C and skip F sharp. An F sharp pentatonic scale would include F sharp, G sharp, and A sharp. No B, C sharp, D sharp, no E sharp. And I'll let you figure out B pentatonic on your own. Start with a B major scale and take out fa and ti. Whole tone scales are made up of all whole steps. So if we go over here to our staff paper, we can write whole tone scales starting with C, and go up by whole steps only. Whole tone scales are symmetrical. They have all whole steps. They also only have 6 notes. And they divide the octave into 2 tritones between C and F sharp and F sharp and C. These are all whole steps, meaning there's 2 half steps in between each member. And like a pentatonic scale, they don't really have a sense of tonic. There's no half steps in the scale, so it has a sense of openness, and it harmonizes with itself at the tritone. Its tonic triad, if you had one, is going to be augmented, and so everything about it is symmetrical and open. So we can write a whole tone scale also on C sharp. Oops. Oh, nuts. So if we start with C sharp, that'd be C sharp, D sharp, F is a whole step, G, A, and B. And then, of course, back to C sharp at the end. So your tritone would be between C sharp and G, excuse me, sorry for the doodle there. And then we've got whole step, whole step, whole step, whole step, whole step, and whole step. What's interesting about the whole tone scale is that only 2 exist. If I go back to, if I transpose it up another half step to D and write my list of notes that are all whole steps apart, notice that I get a similar set, actually the same exact set as my original whole tone scale. They're the same collection, just a rotation of each other. So that means we only really get 2 whole tone scales. C, D, E, F sharp, C, D, E, F sharp, G sharp, A sharp, C, D, G sharp, A sharp, C, D. These are the same whole tone scales. So we call this one whole tone 0, 2 because it starts with C and D. And we'll call this one whole tone 1, 3 because it starts with C sharp. Oh goodness, C sharp and D sharp. So on your worksheet, for a C whole tone scale, this one starts C, D, E, and F sharp, etc. I'll let you complete the rest. F whole tone is the other whole tone scale because it starts on F, not F sharp. F to G to A, etc., etc., etc. So these are going to be the only 2 whole tone scales. This is whole tone scale 0, 2 for C, D, F, and this F whole tone scale is actually the whole tone scale 1. Keep doing that. 1 and 3. But in general, we're starting on F. That creates the 2 different whole tone scales. Finally, octatonic scales. Octatonic scales are interesting because they alternate whole and half steps. See if I got everything off the screen here. Octatonic scales alternate whole and half steps. And if we go over here to our staff, start on C, C to D, E flat is our half step. So whole step, half step, whole step, half step, whole step, half step, and then eventually you get back to tonic. A to B, B to C, half step. This also is divisible by tritone, and its tonic triad is a diminished triad, its diminished 7, the fully diminished 7 chord also lives in this scale. This is the octatonic 0-2 or CD. Additionally, we can transpose this up a half step as C sharp. C sharp to D sharp is a whole step. D sharp to E is a half step, and so on. E to F sharp, whole step. F sharp to G is a half step. And on we go. Whole step, half step, whole step, half step. This is the octatonic scale that starts 1-3. It has so many half steps that it also sounds like there's no tonic. So it's also symmetrical, it's also ambiguous, and if we go down here to our worksheet here, we can create an octatonic scale starting on C-D by alternating whole and half steps. In this case, enharmonics don't really matter as long as you're creating whole and half steps. So C to D, E flat, etc. Because it's starting C-D, you're starting with the whole step there at the bottom. This one's A flat, starting with A flat and B flat. So you start with that whole step, and then you go to the next half step, which would be B natural, or C flat, doesn't really matter. B natural, to C sharp, and so on and so forth. Notice that these are two different scales. The octatonic scale repeats itself after another transposition. So notice if we go to C sharp to D and start with a whole step, this is a whole half, and we transpose it up one more time to D sharp or E flat, and go whole half, so E flat to F, F to F sharp, and so on and so forth. We get back to our original set. So we get only 1, 2, 3 transpositions, unique transpositions of the octatonic scale. I'll stop this here, and I'll make another video that explains the creation of modes.